Sure.
You mentioned some of the great civilizations of the past as you introduced the concept.
Sure.
And I wondered whether this concept of seeing information in a different space and time, whether any other civilizations have ever attempted to explain this in the past, however far back that might be, or is it that we've reached a level with technology that is enabling us to explore this now? And if they did reach it before, what happened as a result of their conclusions?
You know, that's a great question. And you know, as someone who's been conducting some math research, and you know, I'm not going to stand before anyone and say that I'm like a mathematician or a highly qualified math researcher, because you know, I set out with a goal and I had a problem that needed to be fixed, and I've worked really hard to just solve those problems. But what I can say is that if you go back even and look at biblical text, there are clues hidden to understand numbers, even in numeral theology, that help better explain why you even need to have data in why we have 3 dimensions. So if you look throughout history, there are clues written going all the way back even to like the Rosetta Stone, where it explains why we have what we have and why the numbers exist in the way they do. And I think that that's always been at the forefront of human exploration, right? Humans want to know what the future holds, or they want to know where they came from. And I think that the more and more that we start solving some of these fundamental problems, we'll be able to make progress in those areas, because we'll be able to get more information and more intelligence in a feedback loop more rapidly. And I think that it'll really help drive intelligence forward. And I'll give you another great example of that is, you know, right now we're just coming off of the tail end of a global pandemic, right? And it's still ongoing, but it's nowhere near as severe as it once was. And when we really think about what that looks like, you know, DNA, a strand of DNA is a quite large storage medium. It takes up multiple terabytes to store. So in order for us to actually represent a genetic structure of COVID, it's a very large amount of information. And in order for us to actually simulate variants of that, by like treating data like particles, and you know, there's a lot of data that gets generated from something like that. So in order for us to actually simulate genetics to the point of where we can actually start predicting how to respond to new variants that might not even exist yet, we're going to need to start thinking about how to get that 24 terabytes for a single DNA strand all the way down to, you know, very small numbers, so that we can better move it around, better compare it, and better have array matching and all the same fundamentals that really are at the basis of AI, right? I mean, AI is a form of number generation. And that's also another interesting point, because when you're talking about generating numbers, right now here in Europe, we're talking about how you legislate this topic, right? And one point that I would make is that the art of number generation is very similar to the gaming industry, which you have casinos here. Actually, one right up the block here. It's very similar to the slot game industry, where you pull a slot, you get a number, right? And I think that from a legislative standpoint, given that in varying jurisdictions you have varying laws about how numbers can be generated, I think that that serves as a great framework for being able to actually legislate how numbers get generated in artificially intelligent systems.